We know that upstream of our chassis of B-series blades are important local area networks that we want to participate in our UCS system. This nugget is all about that. How do we implement local area networks in our B-series environment? Let's jump in. Now, the first thing you need to realize in the UCS system when it comes to LANs is the fact that our fabric interconnect is very flexible. What do I mean by this? Well, the Ethernet ports on the fabric interconnect can be configured in a variety of what we call port personalities. Interesting concept, right? Yeah, these Ethernet ports can be configured for a particular port personality based on what is connected to that particular port. For example, if we are connecting the Ethernet port upstream to something like a Nexus 7K, and we want the LAN traffic to be carried over that port, we are configuring what we call an uplink port personality. But if our Ethernet port connects down to the B series chassis, then we are configuring what is called a server port. So the flexibility of the Fabric Interconnect is very, very impressive, isn't it? With Fabric Interconnect A selected in the UCS Manager, I'm going to slide over to the Physical Ports tab. So let's say we have this Physical Port 10. Notice the interface role is unconfigured. The interface type is a physical port. Notice it's disabled. There's nothing plugged into it. But if we right-click this port, you'll see what I wanted to show you. Configure as server port. Yeah, configure this port for connectivity down to our B-series servers. Configure as an uplink port. Yeah, configure it to go upstream to something like the Nexus 7K. Configure it as a fiber channel over Ethernet uplink port. Easy for me to say, not so much, right? So yeah, so we can configure this to carry that fiber channel over Ethernet traffic upstream. This highlighted selection I've got going on right here is obviously one of the most exciting things about the UCS environment. Our ability to do that unified fabric carrying fiber channel over Ethernet. And obviously we need 10 gigabit per second Ethernet in order to make that magic happen, as we covered in our CCNA data center course here at CBT Nuggets. A fiber channel over Ethernet storage port. Yeah, if we have a storage device out there that utilizes fiber channel over Ethernet. Currently, vendors supported for that particular feature would include EMC and NetApp. Configure as an appliance port. Maybe we have some particular monitoring appliance out there. We could configure a port personality of monitoring. Not shown here. We go elsewhere to do that, and that's in order to configure our span port that we talked about in our earlier monitoring nugget of this particular course. So, lots of flexibilities with these ports in the UCS system, adding flexibility to the overall infrastructure. But what's your first job when it comes to setting these port personalities in the UCS system? Well, your first job is to literally dictate which of your ports on the Fabric Interconnect are going to be Ethernet ports versus fiber channel ports. Yeah, remember we can have fiber channel ports on these Fabric Interconnects. So what you're going to do is you're going to go to the Configure Unified Ports area under Actions, and it's going to warn you, hey, look, this is where you can convert ports from Ethernet to fiber channel or fiber channel to Ethernet, and doing so is going to require reboot of the module potentially, and doing so is going to cause traffic interruptions potentially. After you read all these warnings, and I'm serious, you would want to read these warnings, you're going to say yes. And now we come into this remarkable interface. Yeah, really remarkable. What you have here is this slider bar right here. And as you slide this bar, you are dictating which of your ports are going to be Ethernet and which of your ports are going to be fiber channel. Notice by default, the role is fiber channel uplink. Okay, so as we slide this bar, we are dictating which of our ports are Ethernet and which of our ports are fiber channel. Obviously, once you dictate which of your ports are going to be Ethernet, you can save the config, reload the Fabric Interconnect, and then you can come in and right-click the physical port as I demonstrated and set the port personality. You can come into these Ethernet ports and you can right-click them, right? And you can dictate the server port, uplink port, etc. So remarkable flexibility in the UCS system thanks to the Fabric Interconnects configuration. Now, when it comes to those important ports shown here, here's a quick quiz. What are those ports? Yeah, those are uplink ports, right? On the Fabric Interconnect, we would define these as uplink ports, going northbound to the LAN equipment. And one nice to have feature on these uplink ports is, of course, port channels. Couple of important points about port channels. Number one, we use port channel IDs, as you know. The IDs that we use for our port channels on the Fabric Interconnects must be unique. So you will indeed get an error message if you try and use a duplicate port channel ID in the system. So let's make sure we use uniqueness. Great news, you have 1 through 256 for port channel IDs that you can utilize. Something else that I want to point out about these uplink port channels is the fact that we are going to use link aggregation control protocol upstream in order to form them on the Fabric Interconnects. Please note that Cisco's proprietary port aggregation control protocol is not supported in the UCS system. In fact, get used to it right now. The UCS system does not like proprietary protocols. So, not to give too much away, but something we're going to talk about here shortly is the fact that VLAN trunking protocol is not supported in a UCS LAN environment. Is this Cisco proprietary? Yeah, I'm pretty sure it is. But regardless, it is not supported in the UCS system. Now, one of the reasons we love those port channels, of course, is because we trick spanning tree protocol. Yeah, we don't have blocking, even though we have the redundant connectivity. You know what else is neat? Even if we're not using port channels, okay? So these are single links. This Fabric Interconnect has 2 links to this 7K, and it has 2 links to this 7K. Even if we are not using port channels, we still have a active link situation for all 4 of these. But wait a minute, how is that possible? Isn't spanning tree protocol going to dynamically block some of these links? Well, no. And the answer is something very, very important I want you to know. And that is, by default, the Fabric Interconnect is operating in what we call EHV mode, or End Host Virtualizer mode. By the way, some literature will present this as end host mode. So you might see it either way, but the key terminology that does not change is end host. What does this mean? It means the Fabric Interconnect looks like a host to the upstream devices. Therefore, they see it as a host with multiple MAC addresses, and they don't do any blocking. They don't do any inactive status on any of these links. So end host virtualization mode, very, very important concept for you to realize. Let's jump into the UCS Manager and see where this is actually set. So if you go back to your Fabric Interconnect and select it in the UCS Manager, notice in the actions there is set Ethernet switching mode. And this says, okay, are you sure you want to set Ethernet switching mode? If you select yes, the Fabric Interconnect will restart and the application will disconnect. Here we are going from End Host Virtualizer mode, EHV mode, to what's called Ethernet switching mode. Of course, I'm not going to do this because now we're going to have spanning tree protocol get involved, and the fabric interconnect is going to act a lot like a standard Ethernet switch. This is very, very rare that we would do this. One case I can think of where we would do this is when we're participating in hot standby router protocol, HSRP, upstream, and we want our switch to act like or fabric interconnect rather, to act like a standard switch. So now you know a very important concept about these fabric interconnects. So when we're in our end host virtualizer mode, let's talk about how things like MAC address learning and those type communications take place. Let's say we've got this B series blade and it is in VLAN 100. And let's say we have this B series blade in VLAN 100, and then we have this B series blade in VLAN 200 and this B series blade in VLAN 200. Sure enough, what happens is this. When the B series blades go to communicate with each other that are in VLAN 100, the traffic never makes it upstream from the fabric interconnect. No need. Inter VLAN, well, wait a minute. Intra, let's use our terminology correctly. Intra VLAN communications take place just fine inside the fabric interconnect logic. You see, what's happening is this direction, the fabric interconnect is learning MAC addresses. For upstream, it is not learning MAC addresses in this nhost virtualization mode. Cool. So to communicate within our VLAN, the fabric interconnect handles that switching no problem. What if this device wants to communicate with this device down here? Well, obviously, this is inter-VLAN communications. We are transcending layer 3 subnets here. And for that communication to take place, the traffic does need to go upstream for the forwarding intelligence required to move that traffic over to the other VLAN. So, I presented this succinctly, but I don't want to by doing that, really diminish the importance. This was a very important discussion we just had. In fact, let me recap it. Downstream from the fabric interconnect, okay, down here, we have MAC address learning taking place. When B series devices inside of VLAN are communicating, the fabric interconnect can handle that with its MAC address learning intelligence for the server ports. When it comes to MAC address learning upstream here with our northbound like Nexus 7Ks and stuff, the device does not engage in MAC address learning. Finally, we pointed out how when inter-VLAN communications are going to take place between a device in one VLAN and a device in another VLAN, that's when traffic has to move upstream in order for the routing intelligence to take place for how we should move traffic to that other VLAN. Now, speaking of VLANs, let's review some basics. First of all, we know VTP is not supported. So this means we're going to have to jump into the UCS manager and we're going to have to create our VLANs. There is indeed a default VLAN 1 in place that we cannot delete. So very important. And we create our VLANs either globally or we create them so that they are fabric interconnect specific. Remember, you could have the fabric interconnect A, the fabric interconnect B, and they potentially could have different VLANs. This is, as you might guess, a rare configuration, and it's most typical that we want global VLANs across both fabric interconnects so that the same layer 2 domain is shared between those fabric interconnects. VLANs can be from 1 to 3967. On most devices, we have reserved VLANs kicking in at 3968. And then we can typically go from 4049 to 4093. Now, I mention this with extreme caution. as far as exactly what VLAN numbers you can utilize in your UCS system. And that's because on more modern equipment, we're starting to get device ranges that are VLAN ranges that are reserved be flexible. Imagine that. The Nexus are starting to do this. I'm sure the Fabric Interconnect system will start to do this, where you can literally go in and say, okay, Cisco, I know you need some VLANs reserved for your own internal functionality. Well, please reserve yourself this block. Isn't that amazing? You can literally dictate which reserved VLANs will exist. I don't think your exam, in fact, I know your exam will not get into these nitpicky details of which are reserved and which are available. So that's really good news. I'm just speaking to you here from a production sense at this point. Okay, now let's talk about our uplinks when it comes to these VLANs. By default, when you create a bunch of VLANs in your Fabric Interconnect, let's say you create VLANs 100 through 200, okay, real typical. You have 100 VLANs, 100 through 200. The default behavior is for all of those VLANs to be allowed automatically on all of your uplinks, okay? No surprise, right? There's no security restrictions in place by default. We create 100 VLANs. Sure enough, on all of our upstream uplinks, all those VLANs are going to be permitted by default. Notice that the ports that we're connecting to on the Nexus 7Ks, for example, those ports must be 802.1q trunks. That's right, we don't like proprietary protocols here, so Inner Switch Link, ISL, is not supported in this environment. We're going to have 802.1q trunks upstream. Can you go in? Can you limit the particular VLANs that are permitted over uplink ports? Of course you can, but by default, all of those VLANs are going to be permitted. Now, as you might guess, the UCS Manager makes it very simple for the VLAN creation, which is good news because we don't have the ability to learn our VLANs dynamically with VTP, as I mentioned earlier in this nugget. So we're going to slide over to the Local Area Network tab. And notice we have our LAN Cloud section here. And notice below that we have our VLANs node. Okay, so here's our VLANs node. Notice I did not lie to you. By default, we have VLAN 1 in the Fabric Interconnect system. This VLAN cannot be deleted. This is our default VLAN. I can go ahead and choose the Add button in order to create a VLAN while selected in this VLAN group. We can give the VLAN a name, right? So I can say, all right, this is the test underscore VLAN. The multicast policy, okay, we have a default multicast policy that we can set for the transmission of multicast traffic in this VLAN. And then this is what's important to us at this juncture, the common global VLAN. Notice we could go in and we could say, okay, look, I want this only on Fabric A. I want this only on Fabric B. Or we're going to go ahead and we're going to configure this VLAN differently on each Fabric Interconnect. So sophisticated options here, but by far the most common configuration is indeed for the Fabric Interconnects to share knowledge of our Layer 2 domain. Then a mandatory requirement, of course, the VLAN ID. We'll make this VLAN 101. And this is a non-shared type of VLAN, right? We're not doing any type of private VLAN infrastructure here. So under sharing type, we say none. Down below here, let me move this window so you can see it. We can check for any overlap. What a nice feature. So we can make sure that we are not having an overlapping VLAN identifier here. We say OK, and we just created a VLAN in the UCS system. We say OK, and there is our VLAN in the UCS. So thank goodness the VLAN creation, quite simple, especially considering there's no dynamic learning potential. So we have the VLAN and the UCS system, and then there is, of course, another place we assign this VLAN, and it's to the network interface card that we have in the B series that is in our chassis. This, of course, makes its way to the input-output module, which connects on up to the Fabric Interconnect. Now, what's interesting is we say it's on the NIC, but really the VLAN assignment is not on the NIC, but it's on the virtual network interface card. Remember, we virtualize here. We assign the VLAN to this virtual NIC, just like we assign a MAC address to this virtual NIC. Oftentimes, we're pulling the MAC address out of a pool of MAC addresses that are available. You see, the virtualized NIC is part of a service profile, and this approach allows us to replace hardware. Yeah, to take this B series device and replace it with another B series device and not lose any of the virtualized identity information. The operating system believes it is on the exact same hardware, even though the hardware is changed. So we'll be getting into much greater detail about all this virtualization in our B series environment later on in this course, but I just wanted to set the stage here for you since we're focusing on the LANs so we can think about the VLAN assignment and the virtualized MAC address that'll be placed on our virtual network interface card. Now let's think about how traffic flows in our Ethernet-based environment for a moment. Do you remember our discussion of the input-output modules and the links that we had? We now know these are called server links, right, for our server ports. We remember that the pinning of traffic is going to be a static activity, remember? And it depends on the number of links we have between the input-output module and the Fabric Interconnect. Well, guess what? For the pinning of MAC addresses across our uplink ports, that can be done either statically or dynamically. How is it done by default? Well, by default, it occurs in a dynamic round robin type fashion. So we're going to have the server traffic dynamically distributed round robin across the available uplinks by default. What happens if a link goes down? No problem. The particular servers that were using that uplink will be dynamically mapped to the surviving uplink, and GARP, Gratuitous Address Resolution Protocol, will be used to notify northbound devices of the particular change. If all of the uplinks fail on the Fabric Interconnect, we want our blade servers to be configured for hardware failover so they can all go over to Fabric Interconnect B. This is a really nice situation, and now they'll be dynamically round robin pinned to the available uplinks on that particular Fabric Interconnect. Please note that that does require configuration of that hardware failover for our blade servers, and that is not some automatic failover that would occur. What would occur by default is that those servers would lose connectivity thanks to the complete and total failure of the Fabric Interconnect and its uplinks. Now, what if for some reason you did want to go up and specify a particular uplink for a particular server? Well, that is what we use a LAN pin group for. That's right, we can literally create a pin group and we can go ahead and ensure that particular blade servers that use that pin group are indeed going to be pinned to a particular uplink. Now, here's an interesting question. What if we have like VLAN 10 through 20 traffic pinned to this particular uplink and that uplink fails? Well, it won't go dynamically to another uplink. What it will attempt to do is fail over to the other fabric interconnect for that particular appropriate interface. So let's just say this was the 1/9 interface. We have a static pinned environment to that uplink. That uplink fails. We'll attempt to fail over to 1/9 on the other fabric interconnect. Now, a new feature that you have in the UCS System 2.0 software is the ability to create what's called disjoint layer 2 domains. What you have the ability to do is associate the uplinks with, indeed, VLANs. Yeah, as I alluded to. So you can go ahead and you can have uplink ports service just particular VLANs. Yeah, so if we have one uplink port that we want to service some VLANs but not other VLANs, we can now manually specify which VLANs should be allowed on which particular uplink ports. There will still be an automatic pinning of the traffic to the server to uplink interfaces, but it's also going to consider the VLAN membership on those particular uplink ports. Now, where would you go to make such a configuration? Well, it's configured in the LAN Uplinks Manager. So we want to make sure that we're on the LAN tab, and then what we're going to choose is the LAN Cloud. And notice there is a link here in the content pane for LAN Uplinks Manager. And this presents a nice interface for us to configure those LAN uplinks, literally allowing us to really not only manipulate pin groups, but as I indicated, to go ahead and take VLANs and associate those VLANs with particular LAN uplinks. By the way, how you would actually do that is you would go to the VLANs tab, and then here on the VLAN tab, you have the VLAN Manager option. And notice we can go to a particular uplink, and to that particular uplink, we can add that uplink to a particular VLAN. This nugget was hugely important in terms of certification. I want you to really watch this nugget several times if you're interested in certification, because we did cover a lot. Think about it. We covered those port personalities. We covered how VLANs are set up and how they work in the system. We talked about virtual NICs, and we talked about how traffic is pinned to uplink ports. We talked about the N-host virtualizer mode. Please listen to me. There are lots of potential certifications laying in store for you here. Let's take a look at a sample one. Which statement is true regarding the default configuration of the Fabric Interconnect? Server-to-server traffic is switched by the Fabric Interconnect. You know what? I like that one. I'm going to go ahead and kind of mark that one. Hey, let me grab my red pen. Where's my red pen? There's my red pen. Server to uplink traffic is switched by the Fabric Interconnect. No. In the default configuration of the Fabric Interconnect, we are in end host virtualizer mode. And in that mode, server to uplink traffic is not switched by the Fabric Interconnect. When we are going to the uplink side, we know that that particular situation is not MAC address learning. No, we rely on the upstream switches for the uplink intelligence, if you will. A MAC address table controls inter-VLAN traffic. No. A MAC address table would control intra-VLAN traffic, not inter-VLAN traffic. So I don't like C. And finally, D, static pinning only is used with the uplink ports. No, we don't like that. We know we can statically pin using our pin groups, but we know by default it's going to be dynamic pinning in a round-robin type fashion on that particular Fabric Interconnect by default. So I love A. Server-to-server traffic is indeed switched by the Fabric Interconnect using a MAC address table on the Fabric Interconnect. If we were to switch out of this default mode, of the end host virtualizer and we were instead to go into switched mode of operation, now the Fabric Interconnect is indeed acting like a switch for the northbound uplinks as well as the southbound server ports, and now everything changes. As a matter of fact, we have ugly old spanning tree protocol that's getting involved in that equation. Well, I sure hope this nugget has been informative for you, and I'd like to thank you for viewing.